All right. I think we'll get started. Still a few of you guys are on the way to the class, but um, online folks are already all online. So again, several reminders. First one on classroom surface disinfection. So Clark and Emma is not here. We'll let her know later on. Homework 3 is still, this is still on Thursday, okay? So we'll probably, we'll finish this chapter by Wednesday, and then about one more day, more than one more day to finish the reminder on the homework, okay? Guys, then we'll do that. Exam 1, again, that's in the week of September 14th, okay? So if you're on the Wednesday, in C section, you'll take the exam on Wednesday in the class. If you are on Friday in C section, you'll take it on Friday. Okay, so you guys will be given 2 different sets of exam for exam 1. Okay. So for the lab this afternoon, bring your face shield if you are coming to lab this afternoon. Okay. I forgot to mention that on Wednesday, but you guys, most of you guys did bring yours. Only 1 or 2 of you forgot that. That's great. Okay. So let me close this door first. So we started chapter 3 last time. We talked about vector. Okay, so if you have a 2-dimensional vector, for example, the displacement, if you go from one place to another place, if you couldn't do one single trip in one line, then you probably do it twice or more than 2 times. But the result is your displacement is a 2-dimensional vector. Okay, so then for vector, now because we are dealing with more than 1-dimensional, we cannot simply use plus or minus for the direction. So then direction will be expressed with an angle, directional angle here. Okay. So now we want to be careful about the labels we are using. Okay, so for vector, if you do a boldface in typing, then they indicate it's a vector. Otherwise, in handwriting, you want to put an arrow on top of letter. Okay, if you are not doing an arrow on top of just the italic form of the letter, then that means that's just the magnitude. Okay, so be careful about that. So Emma, you will be doing the surface disinfecting today. Okay, after class. Right. All right. And so then we talk about vector additions. All right, so you can add 2 vectors graphically, meaning you place the tail of the second vector on the head of the first vector, then the resultant is pointing from the tail of the first vector to the head of the second vector. Okay, so that's how you do vector addition graphically. All right. Now keep in mind this would be a good practice for you guys when you are solving for a problem for vector additions. You want to sketch the vector addition graphically because that will give you a rough idea what the magnitude of the resultant vector should be, and then what would be roughly the angle it should be. Okay, you don't have to be very accurate about that, but it will give you some idea about what are those 2 numbers would look like. Okay, after you do your analytical calculation, then you can compare your answers to these 2 estimations from the graph. Okay, all right. So when you place the second vector on the head of the second, or when you place the tail of the second vector on the head of the first vector, so you are actually moving the second vector parallelly over. Okay, so you can do that because the vector, if you move it parallelly over from one place to another place, then it's identical. It's still the original vector. Okay, that's why you can do it that way graphically. If you are doing subtracting of vectors, a minus b, then you are actually doing a plus minus b. Okay, in that case, minus b then will be the the same magnitude as B, but just pointing in the opposite direction. Okay, so then you can do that. You can reverse the direction of B vector to become negative B. Okay, so then you are basically doing the addition of two vectors now, A plus minus B. Okay, so then place the tail of the second vector again on the head of the first vector, and then resultant vector is starting from the tail of first pointing to the head of the second. Okay. So this is basically you are doing addition or subtraction of vectors graphically. In addition to expressing a vector with a magnitude and then directional angle, you can also do its components. Okay. So then these are the two ways expressing a vector. So components or express vector as magnitude and direction. Okay. You can convert, or you can give in like one piece of information, you can solve for the other piece of information. Okay. So if you are giving components, then you can calculate the magnitude by using this equation, and then directional angle use this equation. Okay. If you are giving magnitude and directional angle, then you can calculate the components with the A sine and A cosine from trigonometry. Okay. We also talk about adding subtracting vectors analytically way. That means we are using the components with numbers. Okay, given. So then you will find the x and y components of the two vectors to be added up, or to be subtracting one from the other. Then for a resultant vector, you simply add the x component of the two vectors up to be the x component of resultant, and the y component of the original two vectors to be the y component of the resultant vector. Okay. Then once you have the two components of the resultant vectors, you can calculate its magnitude and also the directional angle. Okay. So that's the analytical way of doing it. And we also mentioned about caution when you are doing the angle calculation, use your calculator. Okay, so check on your x component when you have the components of the vector determined. So if x component is less than 0, then add 180 to the angle you get from your calculator. Okay, so always check that. If x component is positive, then it doesn't matter. Okay, you can also doing like drawing the vector in its quadrants to see which angle it should be. Okay, or like the range of the angle. Okay. The first quadrant, you should be expecting your angle between 0 and 90 degrees. Okay, and then second quadrant is 90 degrees to 180. Okay, the third quadrant would be 180 to 270. Okay, and then the fourth quadrant will be from 270 to 360, or from minus 90 to 0. Okay, a lot of times in the fourth quadrant, people will just use negative number. All right, so you can do vector addition analytically way by using components. There's a second method that was not discussed in the textbook. Okay, if you're reading the textbook, you wouldn't find this. This is using the law of sines and law of cosines. Okay, from trigonometry. So basically, if you are doing a vector plus b vector, okay, you can sketch it on a graph, and then you'll see that you place the tail of the second vector on the head of first vector. So the resultant is from the tail of the first vector pointing to the head of the second vector. Okay, so then you can see this is basically the original two vectors, and then resultant vector basically forms a triangle. Okay, so then inside a triangle, you can apply laws of sines or law of cosines. Okay, either way. So basically, law of cosines would say the length of this side square should be equal to length of this side square plus this side square minus twice of this length multiplied by this length, and then cosine of this angle. Okay, so the cosine is in the equation, so this is law of cosines. Okay, I'm just listing one of the equations for either law of cosines and law of sines, but you can actually write other expression. For example, you can do cosine of this angle in the equation. So that means you'll be doing b squared, the length of b squared, that will be equal to length of a squared plus length of r squared, okay? And then minus twice of a times r times cosine of this angle, okay? You can also take the angle as well. Then you'll be writing this square equal to this square plus that square minus twice this side times cosine, okay? Now inside a triangle, you can apply law of sines as well. So which says sine of this angle over the opposite side will be equal to sine of any other angle. Okay, say this angle over its opposite side. Okay, so in that way. Okay, and then it's going to be the same on this angle. If you do sine of this angle, then over this length. Okay, will be equal to sine of theta over that as well. Okay, so law of sines over there. So you can see you can pretty much determine the length or the magnitude of your resultant vector, right, by using this guy, if you can figure out the angle between these two, all right? And then you can figure out its directional angle here. So this would be the directional angle of this guy, okay? Now, this is just apply for this figure over here particularly, okay? So in some cases, if your R could be in, if your A could be in this direction, B in that direction, and then that's the resultant angle, okay? So then you'll need additional information about the directional angle for A, but it's case by case, okay? There's no universal expression for the angle. You'll just have to look at the graph you have and then figure out the angle, directional angle graphically, okay? All right. So I think your problem 3 is law of sines and cosines. You can use that, okay, to figure out the magnitude pretty easily using law of sines, okay. So we'll take a look at practice later on, okay, after we talk about addition, velocity additions, okay. So for two-dimensional motion, a lot of times, again, as I say, your motion could be like in one part in one direction and then the second part in a second direction. But we'll look at one-dimensional velocity addition first, okay? To start with, saying somebody is walking on the train with certain velocity, and then the train is going in one direction with another velocity here, okay? So then from the observer, if the observer is standing on the ground here outside the train, he'll see this velocity of this person, the passenger, to be the addition of the train's velocity. So the trains with respect to ground plus the person with respect to the train, right? So then we'll add these two up, okay? So for vectors, especially when we talk about displacement and then velocities, okay? So then you can use subscripts over here. So V, so in this textbook, we'll be just using like, if you are having, so this is a vector, V with the arrow is a vector, okay? The subscript are P and G that refers to person relative to the ground, okay? So it's the first subscript relative to the second, okay? And then here is the person relative to the train relative to the ground, okay? So you can see from this expression, you can see that then person velocity of person with respect to train plus velocity of the train with respect to the ground, it's going to give you the velocity of person with respect to the ground, okay? So it kind of works in this way. The subscript of the first vector, if the second subscript matches the first subscript of the second vector, then that subscript goes away, okay? Then you end up with the V, just PG, okay? So, and then if you are doing like V, say 1 to 2 plus V of 2 to 3, that will give you V of 1 to 3, okay? 1 relative to 3. Okay, so you can see that's the how this works. Okay, so the cancellation happens when the second subscript on the first vector matches the first subscript on the second vector, then last subscript will go away. Okay, so this is from one-dimensional figure, but it also applies to two-dimensional. Okay, so in this case, if train is going in the horizontal way, but the passenger is going up the train with on the ladder vertically, then you can apply that too. Okay, so then v of person with respect to the train plus v of the train with respect to the ground will give you velocity of the person with respect to the ground. Okay, so that also applies. Okay. I think this figure actually it does VTG plus VPG PT. Okay, but when you are doing addition, you can switch the two. Okay, you can do this is the same as VPT plus VTG. Okay, it's same as this guy. Okay, so then at the end you'll get that. Okay, V of PG equals to VPT plus VTG. Okay. Also in this way on here, now sometimes you are using numbers as subscripts, okay? So that then works the same way as well. So say velocity of object 1 with respect to the second object, you can do this, okay? So v12 plus then v23, okay, of object 2 relative to third, okay? Then we'll give you velocity of the first object relative to the third one, okay? So that also works because the 2 here as the match up with the 2 here, so that goes away. Okay. Now here, so sometimes, so if you are swapping the subscripts, okay, so this means from A to B or A relative to B, if you put in the relative motion way. Now then if you switch or swap the two subscripts, then you will get a negative vector. Okay, so it's the reverse of it. Okay, so this is another rule here. Okay, you can see that like relative, right? If my position relative you is in this direction, then your position relative me too should be in the other direction. Okay, so put that in that way. Okay, so we'll take a look on this example here. All right, so this one says a passenger walks from one side of a ferry to the other as it approach a dock. If the passenger's velocity is 1.5 meters due north relative to the ferry, okay, so this 1.50 is the magnitude, okay, and then the direction is north relative to the ferry. And if you are talking about its relative velocity with respect to the water, it's actually 4.50, okay, at angle of 30 degrees west of north. What are the direction and magnitude of the ferry's velocity relative to the water? All right, so I think I will help you guys get started on this one. Okay, so first, let's check the sketch. We'll do a sketch, okay, to see what is this one about. All right, so it gives us two relative velocities. Okay, so the first one is given velocity of the person with respect to the ferry. So you want to write down Vp sub f, okay, person with respect to or relative to the ferry. It says 1.50 meters per second due north, okay. So that's the direction, that's the magnitude. And then it says the velocity of the person with respect to water, that's 4.5 meters per second. And then it says its 30° west of north. Okay, so 30 degrees west of north. So then we need to put this on the graph here. So let's draw a graph here. So instead of doing X and Y coordinate, I'm going to use east to the positive horizontal. And then north to the positive vertical. All right. So we are given two vectors. The first one is VPF in the northward, due north. Okay, so this is like, I'm going to use 1.5. Okay. So it's right on this here. Hope you guys can see this. Okay. 1.5 due north. And then the second one, so this is V person relative to the ferry. The second one is 30° west of north. Okay, so this is east, then this is west. Okay, this is south. So we'll be looking for 30 degrees west of north. Okay, so that means 30 degrees with respect to the north direction. That in this way. Okay, so 90, 80 will be 10, 70 will be 20, and then 60 will be 30. Okay, so it's going to be in that direction, somewhere in that direction. All right, so that's the direction. The magnitude is 4.5, so we need 4.5 here in that direction. So 4, all right, 4.5 there. So right about there. Okay, and over here I'm a little bit over, but and it's somewhere there. Okay, that's 4.5. This guy is 1.5 meters per second. This guy is 4.5. The length. Okay, so this is 30 degree west of north. This is my V person to the water. The problem is asking us what would be the velocity of the person with respect to the water. Okay, so you are looking for V. Oh, actually, I think ferry with respect to the water. Let me double check. I think that's what we want. Yeah. Ferry's velocity relative to the water. Okay, so we are looking for V of F W. Okay. Now we can come up with the ferry with water. We can write it in the subscript form. Okay. So if we are looking for, if we are looking for velocity of ferry with water, then you can write it up in this way: velocity of ferry with respect to the person, right? Plus velocity of person with respect to the water. So this is how you want to do it. Okay. So if there are 3 objects in the problem, then this is what you want to do it. Okay. So one with respect to another, then you put a third one in between. Okay. So V of FP plus V of PW. So that way P and P cancel out, gives you this guy. Okay. We are given 2 velocities here. All right. So the second one is given directly. All right. Now we need this guy, but we are given this guy, right? But if you remember, if you switch the 2 subscripts, then it becomes negative, right? So then this is equal to negative of velocity of person with respect to ferry, okay, which is given, plus velocity of the person with respect to water, okay? Yeah, if you flip the subscripts of a vector, then it becomes negative of the original. Yeah. because this one is given. Okay. Yeah. Right. Mm-hmm. All right. So for you guys online, so the question was why we are doing this flipping of subscripts. Okay. So that's because the that vector is given. We are given, we need this vector, but it's not directly given. So we want to flip that because this guy, the second one here is given. Okay. All right. Now you can see you are looking for you're looking for this guy, you know this guy, you know this guy, right? You know their magnitude and then their directions, okay? So now from this point on, you can either doing it the components way, okay, to figure out its magnitude and directional angle, or you can do the law of sines and cosines, okay? So we are going to check on that. So minus of this guy, that means, okay, so that means you are going to flip the VPF on the graph, okay? So just in the opposite direction, okay? So this is then the vector you want to add. So this is velocity of ferry with person. You are adding this guy, you are adding this and then this up. So you will move this, the second vector parallelly over, okay? Roughly that way. I don't think I'm doing a parallel, perfect parallel, but about that way, okay? So you are moving the second vector, this guy, parallelly down over here. So the tail of it is at the head of the first vector to be added up, okay? So then your resultant should be this guy. Right? So then this will be your resultant vector of what you are looking for. You will be looking for this vector, okay? The V of ferry with respect to water, okay? Now, if you do this, everything in scale and then perfectly parallel, you can kind of take a measurement and see how much is this roughly, okay? It looks like 3.2, okay, to me. And then for the angle, directional angle, you'll take a measurement if you have a protractor. So think for this one, it goes right up about like 140, okay, also. So we'll see that the exact number, okay? All right, so as I say, you can do components way, and then you can do the triangle way, okay? Okay, so let's see. We will take a look at the components way first. So we are doing this vector plus this vector, okay? So this is first vector, this is second vector. We need to know at the x component of the first vector and then y component of it, okay? Now it's pointing right here, so that means it only have the y component. It doesn't have the x component because it's only along the vertical direction, okay? So its x component is going to be 0. So VPF x is 0, right? Oh, yeah, the component, we don't need that, the arrow sign on top, because component should be just referring to the scale quantity. The y component though, so let's say it's 1.5 for the magnitude, right? But it's below the x, so that's negative 1.5. Okay. So we have the x and y component for the first vector, or this guy here. We'll take care of the minus sign later on, okay? Just put the minus sign in front of x and y, that would be fine, okay? All right. Now for the second vector, it's x component, okay? So it's this second vector, so or this guy. So you're going to do the x component, okay? You can do, the magnitude is 4.5, and you can do cosine of the angle of its directional angle. So then if you want to do that, if you want to use cosine, you'll be looking at this angle, okay? This is the angle of it. All right. So this angle will be 30 plus 90, so 120 degrees. If you want to use just this 30 degree, then trigonometry is a little bit differently. Okay, then you're using sine to the x component, and then cosine to be the y component, and then also paying attention to the signs. Okay, because in this guy is in the second quadrant, so the x component should be negative. It's in this way. Okay. Now y component is positive, but if you are doing directional angle, then you don't have to worry about the signs. Okay, it will get you the correct signs. Okay, the y component should be 4.5 sine at 120 degrees. Okay, so let me see. (4.5) of cosine actually give me minus 2.25. Okay, oh, let me put one extra digits here because it's given in 3 digits. This guy gives me positive 3.897 meters per second. Okay, so the x and y component of the second vector, you figure that out. Okay. So then for the resultant vector of ferry with respect to water, v ferry water its x component will be, now you take care of the sign here, so negative of the first one, negative of 0, plus the second one, the x component of the second one here, negative of 2.250 meters per second. Okay, so then just minus 2.250 meters per second. All right, its y component then will be the negative of the first y component plus the second y component. Okay, so negative of negative 1.5 meters per second plus actually, I'm sorry. So if I keep the original one here, all right, its x component is 0, that's right. Its y component, this is the original vector, okay? So it's still positive. Sorry about that. This should be still positive if we're looking at the y component of the original, okay? And then you put the negative sign later on, okay? Then it's positive, still positive there. You can do this one as a vector, the negative of it as vector. To start with, then this component will be negative, okay? But we are taking care of the signs later, the negative sign later, so it's original positive, okay? Now plus the second one, 3.897 meters per second, okay? So this gives us 2.397, all right? So this then is the x component of the resultant and y component of the resultant, okay? So once you have the two components, then you can calculate for its magnitude, okay? So simply, so then the magnitude without the arrow, that means magnitude is the x component square plus the y component square, okay? Minus 2.250 meters per second square plus 2.397 square, okay? So this will be roughly 3.29 meters per second, okay? And then you kind of double check with that. That's about 3.2 or 3.3, okay, from the graph. So I think we are pretty much set with the magnitude, okay, because we have agreement from the numbers and then the graph. The directional angle here, theta of velocity of ferry with respect to water, then you are doing tangent inverse v y component divided by the x component. So tangent inverse, okay? 2.397 over minus 2.250. Okay, that will give you minus 46.81 degree. Okay. So you can see this is a negative number, right? Negative angle. Apparently, it doesn't match up with what you have on the sketch, on the graph, right? So what's the problem here? So the problem is this, the x component is negative, okay? That's what we mentioned. When you have your x component is negative, then whatever you get from your calculator, you want to add 180, okay? So this is due to that. That's all this. Okay, so you add that. Okay, so then this angle is about 133 degrees. Okay, and then this is relative to the east direction. Okay, counterclockwise relative to the east direction. Okay, so you can indicate in this way. You can say this is the east direction, this is my angle. Okay, or you can write in word, say this is with respect to the east direction. Okay, all right, so that's your directional angle. Okay, questions you guys might have? Right, and online guys, you can unmute and then speak up if you have questions. Okay, all right, so this is components way. Now I'm going to show you how to do it this and using the law of sine and cosine. Okay, so I will refer to this graph here. So originally when we sketch this up, then this is the first vector, this is the second vector, this is our resultant vector. Okay, so then we have a triangle here. Okay, on this here. So we know this is the length of this guy is 1.5. We know the length of this guy is 4.5, right? Now, we know this angle, right? Because we move this guy parallel over, so then this angle should be also 30 degrees, right? So we have this side known, and then we have this angle, right? So we can use law of cosine to figure out this length of this side directly, right? This is what we are looking for the resultant vector, the magnitude of it, okay? So by using law of cosines, you can just use one equation to figure that out, okay? Instead of doing this multiple steps, okay? So let's see that. So law of cosine says, so this is what law of cosine says. I'm going to just call this A, this is B, this is C, okay? Or we can use the vector notation here because we have this 1.5, this 4.5, this 30 degrees, okay? We are looking for this guy, which I don't have a better sketch here than the original one, but this is what we are looking for, okay? So then this side, this is the velocity of ferry with respect to water. That's the magnitude we want, okay? This is the velocity of ferry with respect to person or person with respect to ferry. And then this is V of FW, right? So using law of cosines, we can see this side square, VFW square should be equal to VFP square plus VFW square minus twice of VFP, VFW cosine of the angle these two makes 30 degrees, okay? So then V of FW should be square root of all this thing here. So we can take a look there. This guy, ferry to person or person to ferry, the magnitude is 1.5. So 1.5 square, okay? I'm not going to write the units for right now because I know they are all in meters per second. So my result should be also in meters per second, okay? Plus 4.5 square minus 2 times 1.5 times 4.5 times cosine of 30 degrees, okay? So you put all this thing into your calculator, it's going to tell you magically this is 3.29, okay? Just the same as what we got previously here, okay? So you can see the convenience of using law of cosine here, okay? So with just one equation, you will figure the magnitude out. But we are not done yet. We still need to know the directional angle of it, okay? So for the directional angle, then we better refer to the original sketch here. So then we'll be looking for this angle, right? If we are looking for this angle, we probably need to know this angle here from here to there. Then we can do 180 minus this guy to get that guy, okay? Or if we can find this angle from here to here, then we can do this angle plus 90, okay? So either way, we will be able to figure out that. So we know this angle. Now we apply law of cosines. We now know all the three sides, the length of all the three sizes, okay? So then we can apply, because we use law of cosines already here. Now the next is to use law of sines, okay? So to use law of sines, I'm going to just say, because this is 30, this is 1.5, and then this guy, I figured that out, is 3.29 on this side here. So then I can set it up so sine of this over this, okay? So I'm going to set it up that sine of 30 degree over the 3.29. Actually, if I look on my calculator to keep extra digit, it was like 0.28. I think it's 0.287 originally. Okay, to just keep one extra digit. Then that should equal to you can use this guy, sine of this angle over 1.5, or you can use this guy. Okay, so either way, I'm going to use sine of this guy. Okay, so sine of this angle, which I call it angle phi, sine of phi divided by the opposite side, 4.5. Okay, so then from here, from this equation law of sine, you can see you can figure out your phi directly. Okay, so and then you can do the 270 minus this phi to get your directional angle. Okay, so again, this is case by case. If this is the eastward, then this direction is the theta you are looking for. Okay, you're looking for theta. So if you can figure out phi, then you do from this over here is 270, right? Minus this guy will be in there. So theta will be 270 minus phi. Okay. All right. So you can rearrange the terms here. You can pretty much just multiply both sides by 4.5, right, to get rid of 4.5, and then you have this. So this, all this thing together, you can type them into your calculator, okay? And then you can do sine inverse of sine to get rid of the sine function, okay? To get rid of sine, you do sine inverse of the sine, okay? That will give you phi. Similarly, because you are doing sine inverse of right-hand side, you want to do sine inverse of the left-hand side. Sine 30 degrees over 3.287, okay? maybe a little bit messy here, but you should be able to do that in your calculator, okay? What's that? Cross multiplication? Yes. Yeah, and it's the same. Yeah, I mean, pretty much the same. You can do, when you do cross multiplication, then you will further divide both sides by this guy again, okay? So it's easier to do just the 4.5 multiply both sides now, okay? All right, so now if I do this in my calculator, it's going to tell me this is 43.2 degrees, okay? Or 43.20 degrees, all right? Now you see, this is probably not consistent from what the graph shows, right? The graph shows this angle, I call it phi in my sketch. Graph shows this angle should be greater than 90 degree because it has a 90-degree part and then plus this extra, right? On here, it's the 90 plus a little bit extra. So it's not consistent with my graph. So what happens here? All right. So this is the thing, when you do sine inverse of certain number, okay, it actually has two solutions theoretically, but your calculator will just give you one number. Okay, it will not show the other. Because if you look at the for the sine function, if you do sine function, all right, if this is angle, this is sine of the angle, it goes from 0, it goes like this, right? So say sine of 0.5, it will be somewhere here, right? 0.5, let's say it's 0.5. So sine of 0.5 actually have two solutions, one at this end, and then also it has another one at the end, right? So it actually has this number, it has this number, which when it's 90 degree, it has the maximum here at equal to 1, okay? So if your graph shows otherwise, okay, if your graph shows that your angle should be greater than 90 degree, then the calculator will show this answer, but you should take this one, okay? So to get this one, you'll do 180 minus this guy, okay? So, all right. So you need, so this then the correct answer will be 180 minus it, okay, to be 5. All right. So that's why it might be better to pick the angle that's less than 90 degree, okay? So you can calculate that one and then use that side originally, okay? I'm just picking this one to see possibly what problem you will run into on this scenario, okay? So you have to do that. Then this gives you about 36.8 degrees, okay? So then if my phi is this guy, I will take this guy into this here, 136.8 degrees here to solve for my directional angle, okay, of the theta. So that's also like 133, roughly 133 degrees, okay, or 0.2, but to keep 3 sig figure is that number, okay? So that will be consistent with what we got earlier here, 133 degrees, okay? So either way, so sometimes it will be just quite straightforward to figure out the magnitude, okay? But then for the angle wise, a little bit hassle there, okay? So I would say either the components way or this triangle way, yeah, it depends on, it's up to you, whichever you think you feel more comfortable of doing it, okay? But in problem 3 in the next assignment, because it's looking for just magnitude, so then it will be quite straightforward to just use the law of cosine for the magnitude, okay, on that problem particularly. All right. Any questions you guys might have? Right. Yeah. So the question is, if you are using this angle, right? So if you are using this angle, then you will figure out that angle. So you'll do this angle plus this angle, then we'll get you. It will give you. Now it's a little bit messy. Let me just put a new figure here. Okay. So it looks like something like this. In this triangle, this is 30. If you use this angle, and then use the 1.5, 4.5 here, 3.29. If you solve for this one, all right, then actually this guy plus the 30 will give you this angle. And then add 90 to it will be your directional angle, okay? The 90 at this angle will be your directional angle. Or let me call this as phi. Now theta is equal to 90 plus phi. And then phi is equal to whatever this x plus 30. Right, it will give you this, it will give you this angle first. If you do law of sine, okay? If you do sine of this x over 1.5, you can do sine of this x over 1.5 equals to sine of 30 over 3.29, right? Sine of 30 over that is sine of this angle over this. Then you can solve for this x angle, all right? But this x angle, this at this will be equal to this guy from the geometry, because all three angles add up to be 180. But if this angle plus this angle is also 180, so then this angle is actually equal to this plus that. Okay. Yeah, a little bit geometry here. Yeah. So for you guys who are good at geometry, maybe better off using law of sine and cosine. Okay. And then otherwise, it could be it looks like straightforward using components. Okay, but multiple steps. Okay, more steps here. Okay, so either way. All right. Any other questions anyone might have? All right, so let me see. Looks like a couple of you guys are not here in class. All right. Okay. All right, so next, I think I'm going to just quickly talk about motion in 2 dimensions, okay, for the remaining 5 minutes or so. So as we said earlier last time, you might not always have problems with just 1 dimension, and could be having 2 dimension, but because we have learned how to do it 1-dimensionally, so for 2-dimensional motion, it's actually not so challenging. It's basically you are repeating 1-dimensional motion in x direction and y direction, okay? So for example, the turtle here goes in a particular direction. In that way, then you can actually, now in this case, if you are looking for the displacement, so then you will have an x component and y component, okay? You can do either way. You can find its total displacement by doing the overall velocity times time t, assuming it's a constant velocity, all right? And then later on, you can break it into the x and y components for the displacement, okay? Or you can calculate the velocity x and y components first. Okay, so this gives you x component, y component velocities. Then you can do the use the distance traveled in x direction will be equal to the x component velocity times time t, and then distance traveled in y will be equal to the y component velocity times time t. Okay, so either way, you should be getting the same result at the end. Okay, so this is the two-dimensional motion. Okay, so basically you break the motion into two dimensions, and then you do one-dimensional motion along one dimension, and then the other one along the other dimension. Okay, so then when we look at the equation of motions for the position as a function of time in one dimension, you can use that equation x equal to x naught plus v naught t plus 1/2 t. Okay, so for the scenario we just checked in the previous slide, when the turtle, if the velocity is constant, that means acceleration is equal to 0. Okay, so then your final x and y component, okay, should be, you just drop off the terms with acceleration, because acceleration is equal to 0. Okay, so now it's going to be equal to that way. Okay, the x component plus the check the notation here. So if you are looking for distance or displacement in x direction, then you are doing the x component of initial, and then velocity of x component times t. Okay, and then y component is its initial y position plus the y component of velocity times t. Okay, so yeah, so that's how you wanted to do it. Okay, just do them separately. Okay, I don't think we have enough time for the practice problem here for the next couple of 2 minutes, but we'll stop here and then come back on Monday or online. Okay, we'll meet online on Monday to start with the this problem. Okay, all right. Bye.